the second of our regular weekly presentations. Last week we spoke about complexity, one of the evils of systems engineering, and this week we'll be talking about communication. So first of all, for those of you that don't know us, see if I can get my pen working properly. That one's me, and the one with the giant face there, that one's Simon. So I'll be leading the presentation today, but Simon will be joining in as and when he sees fit, or as and when I ask him to. So do you want to say hello, Simon?
Hello, Simon.
Okay, there we go. The old ones are the best.
Yeah,
so,
absolutely.
I will warn people in advance. There's a slightly rude joke on one of the slides coming up, but I will. If you get the joke, then it's fine. If you don't, then that's fine as well. But we should continue. But that's the advance warning. Parental discretion is advised. So this morning we're going to talk about communication in MBSE and why it's so important and what the mechanisms are that we can put in place to help us with our communication. So just to sort of reiterate, one of the things that we often say, and that we certainly said last week, is that when it comes to systems engineering, the basic need for systems engineering is that in real life, it's very, very easy for things to go wrong. If things didn't go wrong, then we wouldn't really need systems engineering. So one of the things that you need to consider is exactly why the things go wrong. Why do systems fail? Why do projects overrun? Why do vehicles break down? Why do airplanes fall out of the sky, and so on and so on? And there's a plethora of literature out there that describes system failures and system overruns and project failures and so on. But fundamentally, there's three underlying reasons that we need to consider and that we need to address when it comes to systems engineering. And these are complexity. So what we really mean by that is the problems are caused by unidentified and unmanaged complexity, and that's what we talked about last week. Communication, so ineffective communication at various levels in our system, and that's what we'll be talking about this week. And a lack of understanding, so really not really understanding any aspects of the system throughout the entire life cycle. And who knows, that might be what we're talking about next week. So the aim is today we're going to discuss just at a very high level exactly what we mean by communication in MBSE and some of the mechanisms that we need to have in place. So if you've investigated MBSE at any level, one of the expressions you will see all the time is that for successful communication, we just need to speak a common language. Okay, and you can't really argue with that. We do need to speak a common language, but then unfortunately, the answer that many people have to this question is when we say, we need to speak a common language, they'll say something along the lines of, well, in that case, we'll just adopt SysML and that will be our common language. This is one of the big myths about model-based systems engineering, and this is one of the things that I want to explore today. I want to explore exactly what we mean by common language, and I want to also discuss why communication languages such as SysML are very, very important and are essential to what we do, but also that there's a lot more to speaking a common language than just adopting a common notation. And that's really the heart of what I want to talk about today. So first of all, let's talk about exactly what do we mean when it comes to communication. Well, the obvious one is different stakeholders that are interested in our system actually want to talk with one another. They want to communicate with one another. And these stakeholders, we'll have a look at a moment, can take on many, many different roles. There's lots of very broad categories of that. We define a stakeholder as the role of any person, anything, any organisation, so the role of any of those things that has an interest in our system. So straight away on here, we can see that there's two lines on this diagram. There's one that goes from stakeholders to stakeholder, that's a communication path. And there's one that goes from stakeholder to system. That's also a potential communication path, because we not only want the stakeholders to be able to communicate with each other, but we also need the stakeholders to be able to communicate with our system, and our system to be able to communicate with the various stakeholders. But there's more to it than just that as well. It's more than just making sure that the stakeholders can communicate with our system. We need to make sure that in different levels of our system hierarchy, so here we've just got on the right hand side just a very simple system hierarchy where we have the basic system is made up of a number of subsystems. Each of these subsystems interacts with various other subsystems. That's what that line there is telling us. We also have to bear in mind that each subsystem is made up of a number of assemblies, and that each assembly interacts with a number of other assemblies, and also that each assembly is made up of a number of components, and each component interacts with other components. So all we've got here, all this is supposed to represent is a very simple four-level hierarchy that represents a system. This may reflect the kind of thing that you've got in your organisation. It may not. If it doesn't, it's actually reinforcing the point that we're making today. And as we go through the presentation this morning, this is one of the things that we'll start to explore, is exactly what is the what do we mean by some of these terms, particularly when we start to talk about the domain-specific language. So let's focus, just for the point of the discussion, let's focus on a single interaction that we have on this diagram. We're actually going to focus on that one there. So I can work my, there we go. So what this diagram is telling us is that, yes, stakeholders communicate with one another, but it's via a common language. And this is where the common language comes in. And yes, I'm showing it here just from stakeholder to stakeholder, but you have to bear in mind it will also occur here, 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 and here. In fact, anywhere where there's any sort of interaction and therefore potential communication between the different aspects of the system. So this is what I'm going to focus on for the point of the discussion, is we're going to consider stakeholders and actually how different stakeholders might communicate in different ways. So first of all, let's have a look at the different types of stakeholders that we may have. So this diagram here we use all the time. This is basically just different types of stakeholder. So this is types of stakeholder. We take this from various ISO standards such as 15208, 15504 and so on, and it's just a generic model of some of the, at a high level, some of the different types of stakeholder that have been identified. And we've got three broad categories. We've got customer, we've got external, and we've got supplier. On the supplier side of the stakeholders, we've got three broad types. We've got managers, we've got scientists, and we've got the engineers. We can think of these stakeholder roles almost as the us roles, if you like. These are the roles involved in actually developing the system that we're concerned with, the system of interest, if you like. On the other side, we've got two categories that represent the them roles. Okay, so for example, customer is the obvious one. We'll have things like end users who actually get direct benefit from the system and use it in some way. Operators who make the system run on a day-to-day basis, and also sponsors who are responsible for funding the project or making the funds available for the project or for the system. In the middle here, we've got what we call external stakeholders. And broadly speaking, we've got a number of different categories here. The two we're looking at are standards and legislation. Now, when we talk about stakeholders, all of the stakeholders, we know that they have an interest in our system. That was the definition that I provided earlier. But we need to appreciate that all of the stakeholders must get some sort of benefit from the system. Okay, that's also one of the defining qualities of a stakeholder. And what that means is we've got to keep all of these different stakeholders happy when we deliver our system. I said we can think of the suppliers as the us and the external and the customers then as the them. The big difference between these two, the external and the customer, it really comes down to how much you can compromise with them. So for example, if you can't meet all of your requirements, you can talk to the customer and usually find some sort of compromise, usually find some sort of middle ground. If you can't comply with legislation, then it's either impossible or it's a lot more, it involves a lot more effort to actually find some sort of compromise or to not comply with something like legislation or something like standards. So this is just a very broad group of stakeholders that we're just going to use as the basis for the discussion. I want to focus on what we've got up here now, which is the common language. So all of these stakeholders are communicating via this common language. And this means that users might communicate with users, users might communicate with operators, operators might potentially communicate with engineers and so on. In fact, any of these potential interactions on there, any of these potential communication paths can occur. And obviously this is going to lead to a lot of potential for ambiguity and miscommunication, because what we need to consider is this idea of the common language. Now, this is the crux of what we want to be talking about today, is when we talk about a common language, there's actually two types or two aspects to that common language. There's what we call the spoken language, and there's what we call the domain-specific language. And one of the points that we'll be making this morning is that we always need both of these things. We certainly need both of them in order to do successful model-based systems engineering. So what I'm going to do now, I'm going to look at each of these in turn and give examples of exactly what we mean by the spoken language and exactly what we mean by the domain-specific language. So when we talk about a spoken language, this is essential for any MBSE endeavour. And really what we're talking about is a basic communication mechanism. It's the basic language that we need to apply on a day-to-day basis for essential communication. So when we get the sentence that we saw earlier, surely we just all need to speak a common language. And then somebody says, yes, well, we'll just talk about, we'll just use SysML, for example. Just having a common spoken language does not imply no ambiguity, and it does not imply there'll never be any misunderstandings that are going to be there. We're going to explore this. We're going to explore this on the next couple of slides. So as humans, when we talk about a spoken language, we talk about things like writing things in English, the spoken language. Another spoken language is German. So forgive me, any Germans or Stephen Paoli, if they're on this course, die gesprochene Sprache. Simon, would you like to read out the third one for us, please?
La parolata lingvo, the spoken language in Esperanto.
There we go. So the spoken language is Esperanto on there.
It actually technically means the language that is being spoken.
Sorry, nodded off for a moment there, Simon, but let's continue. But the point there is we've got lots of different spoken languages that we use as a basis for communication. And this isn't necessarily a problem, because typically we'll know that we're speaking a different language from one another. We'll know if somebody's speaking English, German, or Esperanto in this case. As we can see, Simon does know a little Esperanto, and it may surprise you to know I do know a little German. I'll warn you now, the rude joke's about to come up. There we go. There's an example of ambiguity in language. I know a little German. Before anybody says that that's racist, go and watch the film Top Secret from 1984, and that will mean something for you. If you get that joke and you think that's funny because you've seen the film, that will be even funnier. But we won't dwell on that particular slide for any longer than we have to. When it comes to model-based systems engineering, and we talk about the spoken language, this is where something like SysML comes in, the systems modeling language. What SysML is giving us is the basic communication mechanism that's going to allow us to communicate on a day-to-day basis, okay? And that's it. That's what it's bringing to the table. So saying let's all adopt SysML is the same as saying let's all speak English on a project. It doesn't mean that we'll never have any ambiguity again. It doesn't mean that we'll never have any misunderstandings again. And so that's the first thing to get across, is this myth about SysML. If we all adopt SysML, then actually that's our common language taken care of. Another myth about SysML is that if we do adopt something like SysML, we can't use any other language that exists. So, for example, we might look at something like UML, the Unified Modeling Language, or BPMN, the Business Process Modeling Notation. Now, all of these are owned and managed and configured by the Object Management Group. They're all spoken languages, essentially. there's nothing to stop us on a single project associated with a single system to speak all three of these different languages. The way to imagine this is if you work on an international project, there'll be people working in different countries whose first language is not the same as yours. And this is the way to view something like SysML. It's just the spoken language for model-based systems engineering. There's nothing wrong with having more than one spoken language. And we certainly need to acknowledge that there is more than one spoken language out there. Clearly, there's an optimum level of spoken languages. Too many spoken languages, and we just end up with a Tower of Babel effect where nobody can communicate with one another effectively because there's so much translation that needs to come on. Just focusing on a single common spoken language and enforcing that across an entire project can also be difficult and can also lead to problems, because we have to bear in mind that naturally different stakeholders will speak different languages, and also, which is news to some model-based systems engineers, not everybody is fluent in SysML. Not everybody wants to be fluent in SysML, and SysML, quite frankly, scares many people, and even a lot of systems engineers we see. So we have to bear in mind that when we talk about a spoken language, we shouldn't be trying to limit it to just one. Obviously, we want to keep the number down, but we shouldn't be trying to limit it to just one. I should also add in here that the three examples we can see there are what we call visual modeling notations. They use graphics, they use diagrams as the basic communication mechanism, but there's nothing to stop us in any real project also using things like mathematics. Okay, it might be a formal method such as VDM or Z or something like that. It might be some sort of simulation language. It might just be good old-fashioned mathematics representing different properties of our system, representing different parametrics of our system, for example. Other things to bear in mind, and this is, again, can sound surprising sometimes, but actually, when we're talking about MBSE, text is a valid language. There's nothing whatsoever wrong with text when it comes to model-based systems engineering. However, what we need to make sure, and we're going to explore that on the next slide, is that when we do things in text, the text is consistent with the underlying model. And that's what's essential for all these different languages. We might also have a tabular type language here, and there's nothing wrong with that either. In fact, any real project will usually see a mixture of these different types of language being used by different groups of stakeholders. The challenge then becomes, of course, how on earth do you map between them? How on earth do you ensure that we can actually translate between these different languages? So if we move on now and we go to our classic, I'm not going to go into this in a massive amount of detail. Many of you would have seen this before, our MBSE in a slide. There's three major aspects of MBSE that we need to consider. There's what we call the approach, there's what we call the system or the goals, and there's what we call the visualization. When we talk about the approach, what we're really talking about there is the process sets that we're following, the framework that we got in place, so possibly the architecture framework that we got in place, the ontology that we'll talk about later, and the definition of the viewpoints. This is the part of MBSE that's going to define what things look like. It's going to define the content, the structure, the rationale. So why do we want to do it in the first place? Why do we need each of the views? The system here, and sometimes we refer to this as the goal, is really what we have to bear in mind is that MBSE is all about that. It's all about delivering a system. Okay, that's our goal, and we must never lose sight of it. When we talk about MBSE as opposed to classic systems engineering, the major difference is all the knowledge, all the information, and all the data associated with our system is abstracted into a model. If we want to know anything about our system, we interrogate the model. The basic unit of a model is a view. So we have a number of views, and these views must be consistent with one another. If these views aren't consistent with one another, it's not a model, it's a collection of pictures. We've also got to bear in mind that when we have a view, we need to ask which stakeholders we want to look at it. Why would they want to look at it? What benefits would they want to look at it for? What benefits would they derive from looking at it? And also, what's the structure and content of a particular view? These are questions that we answer when we look at our viewpoints, when we look at our overall framework, but that's a discussion for another day. What I want to focus on today is this side of things, the visualization, the notation. This is where our spoken language sits. It's in our notation, whether this is a visual notation such as SysML, a mathematical type notation, whether it's a text-based notation such as structured text or tabular or whatever it's going to be. We're using the term diagram there in the broadest sense of the term, and when we talk about diagrams, we're also including text in that. So we often refer to, in the context of SysML, we will often refer to text as diagram number 10 when it comes to things like SysML. What's important on this diagram is this, for today's discussion, is this line here. The notation, the diagrams, so the SysML, the BPMN, the UML, the maths or whatever, they allow us to visualize these views. And by allowing us to visualize the views, we can then analyze them, we can help to understand them and so on. But very importantly is this number here. There's any number of different ways we can visualize the same view. That means we can have a single view and we could visualize it using SysML. We could visualize it using UML, using a table or whatever. Let's imagine that we had a set of requirements and we wanted to describe the requirements using text. Obviously, I could just use text to do that. However, I could get across, I could convey, I could communicate exactly the same information using a tabular notation. I could use a SysML requirement diagram. I could use a class diagram in UML. So the point here is we can take the same set of information, the same view, and we can visualize it in any number of different ways, depending on who it is I'm speaking to, depending on which stakeholder I'm speaking to. So for example, if we keep going with the requirements, if I'm talking to systems engineers, I might choose to use SysML and requirement diagrams. If I'm talking to software engineers, I might choose to use class diagrams in UML. If I'm talking to managers, I might use a tabular format, or if I'm dealing with sort of people involved with contracts, it might be a tabular format. It doesn't matter. What we need to do with the spoken language is choose the most appropriate language depending on the stakeholder that I'm talking to. For some stakeholders, this will be SysML. For other stakeholders, it might be UML. Doesn't matter. What we need to make sure is that in order to communicate effectively on a basic level, on an everyday, day-to-day basic level, that we can talk the relevant language with a particular stakeholder. And that's key to successful model-based systems engineering. Yes, SysML is very useful. It's a very powerful language. We use it on a day-in, day-out basis. But there are other spoken languages out there, and we have to bear in mind that not all stakeholders are familiar or comfortable or are even interested in SysML as a language. Right, so that's the spoken language. I want to talk a little bit now about what we call the domain-specific language, which is the other half of the common language. When we talk about a domain-specific language, what we're really talking about are the concepts and the terminology that are specific to a particular, it could be a domain, obviously, an organization, a stakeholder. The main point here is that these things are context dependent. Now, previously, we spoke about the common language and we said we can use the common language to communicate between stakeholders. So let's keep that going as the example. And this time, we got the same expansion of the different stakeholders here, but this time let's consider those different stakeholders and let's take the word function. Okay, function is an English word. It's in the English language. So if English was our spoken language, and I said to everybody involved in this call, do we know what the word function means? Everybody would agree and say yes. If we had 20 people in a room and said, do we all know what function means? Everybody would say yes. If I asked each of those people to write down exactly what they mean by the word function, I would end up with at least 20 different definitions of what that word means. And that doesn't mean that one would be correct and 19 would be incorrect. In reality, probably all 20 would be correct, but it differs depending on the context, because the domain-specific language is taking is identifying concepts and associated terminology with them. So, for example, with the word function, if I talk to, let's say, a scientist over here, let's say a mathematician, a mathematical function is very different from, let's say, a biological function. If I talk to a manager here, they might be referring to a job function or even a department in an organisation. If I talk to an engineer, it might be a mechanical function or an electrical function or a software function, for example. If I talk to an end user over here, they might think I'm inviting them to a party or something like that. But the point here is I can take the same term and I can interpret it in different ways depending on my context, depending on who I am or what domain I'm working on, what particular discipline that I'm working in. So all of these definitions of the term function are perfectly valid in the appropriate context. The danger that we have is that when we embark upon any systems engineering endeavour, we start to make assumptions that everybody has the same domain knowledge that we have. And so it's essential that we can capture that domain knowledge and we can make it absolutely explicit exactly what we mean by the concepts that we've identified and by the terminology that we're using to identify them. Okay, I'm going to give another example of this now and take it a little bit further. What we find is, so Simon and I are fortunate in that we work in lots of different industries, but what we always find is that different industries speak very, very different languages, and we see this all the time. I'm going to put 3 examples up on the next slide, and I'm going to explore the term need. Okay, so before I put the next slide up, I want everybody to just think, what exactly do you understand by the word need? So let's say I've got a need that describes the system in some way. So just think in your own head, what exactly do you mean by need? Okay. Now, first of all, people say, well, why are we using the term need rather than the term requirement? The term requirement is very, very widely used. If you look at the ISO standards, the modern ISO standards, rather than use terms like user requirements now to mean everything associated with the system, they tend to use expressions like stakeholder needs. And they tend to say things like, well, actually, a requirement is just a special type of stakeholder need. So what I'm going to do on the next slide is explore 3 different definitions of the word need from 3 different industries. Okay. Before I put it up, I'd like to point out that all of these are real examples that we've taken from actual organisations in specific industries. Okay, we're going to use that as a discussion point in a moment. So here we go. So first of all, let's look at the left-hand side over here. Here's an example from the aerospace industry where they say, actually, yeah, we do have this concept of a need, and there's different types of need. The 3 types of need that we have are a goal, capability, and a requirement. These are 3 types of need. Whenever we're trying to define types of things, there needs to be some difference between them. There needs to be something that makes them special from one another, that allows us to differentiate between them. So here, for example, we can see that capabilities satisfy goals. We can see that requirements describe capability. Okay, that's a valid definition from one particular area of aerospace. I would like to say now, if you work in aerospace and you don't agree with this, that's fine. It's just re-emphasizing the point that we're making here, is that every different organization, potentially, all different industries will use different terms to represent the same information, or sometimes the same terms to represent different information, as we'll see in a moment. Let's look at another example, the one on the right-hand side. This is taken from the world of automotive. Okay, and again, I'll stress these are all genuine subsets of an ontology that we've taken from actual organizations. We've still got the concept of a need here. We've still got 3 types of need. So actually the structure here and here is very, very similar. We've still got the idea of a goal, and we've still got this idea of this thing here satisfying that goal. So that's telling us that these 2 things, there's a good chance they might be similar in terms of the context. But the word here is feature. It's not capability. If you talk to most people in the automotive world, they don't describe a system in terms of capability. They'll describe it in terms of features. Likewise, if you talk to people in aerospace or defence, they will talk about capabilities, and they will have the word feature, but it will mean something quite different. Okay, so here we've got an example of what's potentially the same concept, and I'll say it's potentially the same concept because when we're modeling and we start to see patterns that look the same, one of the things that we can sometimes abstract from that is if the pattern is the same, if the shapes and the lines between them, so ignoring the words for now, if the shapes and the lines between them are the same, as we can see all three of these are, very often that tells me that the concepts that underlie this are actually the same as well. What we can see here is, let's say that these are the same concepts. In some situations, we've got the same terms. In other situations, we've got different terms. Okay, we've got different definitions here. This one says describes. This one says is derived from. Notice here the potential for ambiguity now. And again, I'll stress this is a genuine example. We've got the word function here. Okay, now bear in mind previously when we spoke about the word function, that didn't feature on there at all, but here we've got an automotive organisation where the term function is the equivalent of what somebody in an aerospace organisation might refer to as a requirement. So just imagine now the potential for confusion, the potential for miscommunication, the potential for ambiguity, if you're not aware of these different definitions that are being used for the same terms. Simon and I have been involved in the medical community recently, and as when we get involved with new areas, it's always an eye-opener. And
that's not as patients, by the way.
Yeah, not yet. So Simon's not well known for his patience anyway. So what we got here is this idea of three different needs again. So notice the same pattern, okay? And as it turns out, the same concepts, but look at the terminology that's being used here. User need is the equivalent of a goal, is the equivalent of a goal here. You might be able to say, well, actually, that you might be able to infer that from just looking at the things. But actually, what about the term design input? Now, that for me as a non-medical person, that was just a weird expression. And when we questioned that and said, where did that word come from? That comes from the medical standards. This is an accepted term that is used in the medical industry. Okay, that we might refer to as capability in aerospace, that we might refer to as a feature in automotive. Just look at the difference in terminology that's being used there. Here, we got a thing called subsystem requirement, and again, this is coming straight from the ISO standards that apply to the medical industry. Okay, but so just look at the sheer difference in terminology that's being used between these three mini ontologies. Even though conceptually they're the same. Okay, so this is an example of what we mean by these domain-specific languages. We'll have the same concepts in this case. So the concepts of need, but here we've got goal, and user need, capability mapping onto feature and design input, and requirement mapping onto function and subsystem requirement. Without visualizing these, without looking at the relationships between them and trying to get an understanding of exactly what we mean by these terms, all we're doing is comparing words, okay? And it's very, very difficult to compare words. So this is why it's so important. It's absolutely essential to have this, this domain-specific language that we're talking about here, okay?
John, I don't know whether you're going to say anything about this, but if not, can I just jump in here that this mapping of same underlying concept, different contextual name was the topic of Stephen and my paper that we did at ASEC last year.
Yep, well, I wasn't going to mention it because obviously I never mention anything that doesn't have my name on it. So, but yes, but that was exactly what you're talking about there with the variations on the ontologies, wasn't it? The different terms for the same.
Absolutely, yeah, and how we can capture that when we're doing these multi-organization ontologies.
Now, the advantage of doing that, so following on from what Simon was saying, is if we can capture these different domain-specific languages. If you think about a spoken language, if I'm speaking English and somebody else is speaking German, we know that there's going to be a problem, and so we can assign a translator. We can find out what the translation rules are, and that means we can actually communicate effectively. It's no different from the domain-specific language. The problem we have with the domain-specific language is it's not as obvious. It's obvious if I'm speaking English and somebody else is speaking German. It's not so obvious if I'm using the word function here, which is a word that somebody else is using in aerospace and somebody might be using in medical, that's actually got a completely different meaning. So by identifying these different ontologies, and then what we can do then is start to identify the translation rules between them. So we can say, well, actually, this one here, user need, maps on to this one here, maps on to this one here. Design input maps on to capability, maps on to feature, and function maps on to subsystem requirement, and subsystem requirement, the path's gone a little bit weird there, maps onto the requirement there. So it's fine to have these different domain specific languages, don't get me wrong, because it's a natural thing to have, but what you need to be able to do is identify when people have these different domain specific languages and then map between them. And this is one of the many, many reasons why the ontology is so important when it comes to model-based systems engineering. So if we revisit MBSE in a slide now, we notice that the ontology actually is sitting on the left-hand side over here. The spoken language, the notation, the spoken language sits on the right-hand side. Conceptually, and this is one of the reasons why this diagram is laid out like it is, that they're apart. Conceptually, they're in different parts of our MBSE in the slide. That's important. We need both of them, but they're not the same thing. So when it comes to something like SysML, SysML sits here, and don't get me wrong, we need something like SysML. We do need the spoken language. And as we said, very often in MBSE, that will be SysML. We absolutely have to have that as an essential communication mechanism. However, equally important is that we have to have this domain-specific language here in the form of the ontology. And the ontology, if you've been involved with MBSE, you'll know is the cornerstone of everything that we do in MBSE and drives everything that we do in our MBSE activities. So just to summarize then, when we talk about communication, the thing that people always say, the sentence you will always see, is that we need to speak a common language. There's two aspects to this. There's the spoken language, which is the basic communication mechanism. And for example, in everyday life, this will be things like English, German, Esperanto, and so on. In MBSE, this will be things like SysML, maths, text, and so on. In an ideal world, we'd all speak the same language. But as we do know in the real world, that just doesn't happen. So it's the same. It would be great if we all spoke the same language, but in reality, we actually need these other languages as well. And that's fine, but we need to understand how to translate between us. And that's where the approach in our MBSE in a slide comes in. The domain-specific language, on the other hand, it relies on the fact we've got a spoken language in place because we need that in order to specify our domain-specific language. But this is really the concepts and the associated terminology that relates to my specific context. So it's context dependent, whether that's a stakeholder, the organization, whatever it's going to be. In MBSE terms, we realize this using the ontology. Conceptually, the spoken language and the domain-specific language live on different ends of MBSE in a slide, okay? But we need both of them. We always need both of them for successful MBSE, okay? So that wraps up the formal part of the presentation. As usual, the slides will be available, and we figured out now how to do the video, I believe, Simon, so we will make that available as well to people.
Yeah,
as usual, here's our shameless self-promotion. Go and buy all of our books. If you want to buy more, buy all of our books and get a free shrine. If you're interested in learning more, don't forget we got our first public training courses coming up over the next few weeks. So next week is Introduction to MBSE. The week after that is Introduction to SysML, and then we're repeating Introduction to MBSE. And we got our free events every Thursday, certainly for the duration of the lockdown. We'll see what happens on the basis of that. We've got about 2 minutes left, so if there's any, I'll ask Simon to sort of wrap up on this or anything he's want to say. If people want to join us for a discussion about this or anything else that they want to talk about in terms of MBSE, we'll be having a short break for 15 minutes, and then we'll be doing the model-based social events. If you want to know more, please go to our website. As I said, please join us for the social event if you'd like to. Simon, any closing comments?
Yeah, just a couple. Yeah, about the videos, we're putting those up on our YouTube channel. So there's a link on I think on the front page of our website to that. Stephen Powley's put in the chat a couple of links to papers that we've done on this topic, the one that I mentioned and another one that I was involved in.
And is he correcting my German as well?
I don't know about that. So they're available in the chat. As John said, we're ending this session now, but we'll be starting the social in another 15 minutes or so. Okay. Cheers. Thank you.
Okay, well, in that case, everybody have good weeks. Everybody stay safe. And if you want something to do over the Easter holiday, you could do a lot worse than watch the film Top Secret starring Val Kilmer that's available on Amazon as a download. Okay, cheers and guys.